Hi out there, today we are talking about linked lists. Well, linked lists is a container for data that can store an infinite amount of elements. And important, there are duplicates possible, what is contrary to a set, for example, where you don't have duplicates. Well, it is a sequential data structure where you always have a predecessor and a successor, a part of the initial element and the last element. And it has one important property, and that is that it is iterable. And with that, we can iterate through the list and manipulate it or insert elements or search or something like that. And it supports like all common actions on data structures like insert, delete, sort, and so on. Well, usually you have items of the same type in it, and you usually have access to the next element over an pointer to the next element. Well, the anchor is usually the initial element. You don't see that here in the picture, but you will see in the next one. And you have different types of lists that are important for searching, how you traverse the list, how you insert elements, and so on. One is, for example, that you have a double linked list where you have as here in the picture, a next arrow from one element to the next one, as well as a previous pointer from the item 2, for example, here to item 1. And then you can also have a pointer to the last item in the list, which makes it a little bit easier for inserting elements. Alright, so let's have a look at the add operation. Well, if we want to add a list, initially it is empty, so we have just our anchor. And our anchor is just an element that signals here starts the list. Well, and it points for now. The next is a pointer to a possible element. Then the next points to the next element. Alright, and currently it just points to null. And if we want to insert an element, then we have to change the next pointer of the anchor to our element. In this case, it is item 1. So we create the item and then we set anchor.next to our item 1. Alright, and as you can see, our next pointer from our item 1 is now null. So this signals the end of the list. Alright, if we want to input another element, for example item 2 here, then we have to do that similar to our anchor. We have to set our next pointer of item 1 to our item 2. And as you can see, the next pointer of item 2 points to null here. Alright, how to delete an element? Well, generally we need another empty element or another pointer to an element. And we'll see in a second why. At first we have to find the element that we want to delete. I imagine here deletion by value, so if data equals data. Here's a little mistake in the slides where there should be item 1, item 2 and not item 1, item 1. But anyway. Alright. Imagine we find our node n where item next is the node that we want to delete. For example, here item 1. So we have anchor, and anchor next shows the data of item 1. Alright, then we found now our anchor as the node n. And then we set a temporary variable, a temporary pointer to item 2, and that is the anchor.next.next, in this case the bottom item here in the list, in the picture. Alright, so we take our temporary variable and say it equals to our item. Alright, so we basically split up our list now, and we can delete our item as the next item of the anchor, because it doesn't, or otherwise we would also lose the pointers to all other elements after this item 1. Alright, so now we can delete the item 1 because it is not relying, or our list is not relying on it anymore. And so we delete it, and in the next step we set our anchor next to our temporary variable. So we connect the list now again, and we could say our temporary variable is like our item 1 now. And like this we deleted the element. Alright, so let's implement that in Python. At first I create a new variable, linked list.python, and I create a class called linked list. And what we need here is a little helper class, such that we can insert values to our linked list, and we don't have to struggle around with another item type or whatever. So we just do that, and we just suggest that we don't get any node, we just get a simple value. So we say class list item, and this has just a value, and that is none for the moment, and it has a pointer next, and it points also to none. Alright, that's all we need in this list item. And next we create our anchor variable, and that is a property of our linked list, so we put it in there. Alright, so now we can start to insert elements. Well, let us at first define the add function for adding new list items to our linked list. So we say that add, that gets self and a value, and then we say append a new element at the end of the list. Alright, so we have to create a new element now at first. So we say our node equals, and we say it is list item, and we have to use self here, and then we say node.value equals value. Alright, now in the next step we have to check if the anchor, we can set here the anchor actually already to list item, because we are just interested in the next pointer of our anchor. So we say if anchor.next equals none with self, because it is a class property, then we set our anchor self anchor.next equals to our node. Alright, and otherwise we have to iterate through our list now till we are at the end. So we need a temporary node, tmp node here equals list item, Oh no, we can already say that it is anchor.next. And then we say while team_p_node is not equal to none. So that means that that an element exists. Then we say that oh no, we can even take a .next here, because we want to find the item at the last position, and if team_p_node.next is equal to none, then we are at the last position. Then we say team_p_node equals to team_p_node.next. Alright, so we are at the last element now, and then we can say team_p_node, that is our last element, .next equals our node. Alright, so that should be it for inserting an element. So let's try that out. I want to create a print method for our list quick. So I say def print self, and we say print the whole list, and there we say team_p_node, we need a temporary node again, is equal to anchor.next, and then we say while team_p_node is not none, we say, oops, we need a self here again, we say print team_p_node.value, and then we say team_p_node equals team_p_node.next. Alright, so now we can try if that works and hope that it does so. If name equals main, then we say L equals list, or we call it linked list, and then we say L.add 1, L.add 2, L.add 3, then we say L.print, and let's say a print up here before we insert anything, L.print. Alright, so that looks good. We don't print anything when it's empty, but we can say here if team_p_node equals to none there already, then we can say print none. So that should print none now when it's empty, and that looks good. Alright, so let's delete an element. Then we say def delete self and the value we want to delete. And now we need again a temporary node equals to, and there we say self anchor.next, and then we say while team_p_node is unequal to none, and then we have to check if team_p_node.value equals value. Let's set that here to anchor, and then we say team_p_node.next.value because we want to start at the next element. Then we delete it. Here we say delete team_p_node.next or team_p_node.next, and otherwise we say team_p_node equals team_p_node.next. Alright. And here we can already say if team_p_node.next is not equal to none, because the anchor won't be none for sure, and we always want to check team_p_node.next. Alright, so else team_p_node equals to team_p_node.next. Yeah, and that's right here because we didn't do any statement there. Alright, if it is equal, then we say we need another node, help node. Let's call it like this, or let's call it helper node. So we can say that equals to team_p_node.next.next. Alright, and that exists for sure, either it is none or it is another node. And then we say delete or del team_p_node.next, and then we say team_p_node.next equals to our helper node. And that should make the deal. And then, since we did everything, we can do a break here. And we say here, delete the first occurrence of the value in the list. Alright, so let's try that out. Let's say l.delete here. And we want to delete the 1 now. Then we say l.print. Then we want to delete the 2. Oh, then we want to delete the last element. Oh, let's start with 1 in the middle, 1 in the beginning, and 1 in the end. Alright. And that looks great. We have our normal list here, then we deleted the 2, then we deleted the 1, and then we deleted the 3, and then it says print none. Alright, that is it for linked lists and all the other operations that you can imagine rely on this scheme of finding a helper node, setting it to next.next, then inserting 1, deleting 1, or doing something like this, and then stopping and do the next operation. But usually you really need a helper node to store some data in the linked list and keep going with the operation. Alright, I hope you liked this video. If it helped you, give it a thumbs up, and subscribe to the channel if you didn't do that yet. And you can have a look at my other videos. They're good ones. I do also a lot of sorting algorithms and other data structures. So have a look there. Alright, have a great day, bye.